Hello my friends and welcome back to KrossUSA channel. From the pine forests of Mississippi to the emerald hills of Ireland, witness how modern sawmills transform raw timber into precision lumber. Today, we're taking you inside two world-class operations, where century-old craftsmanship meets cutting-edge technology. You know, there's something truly magnificent about watching a modern sawmill in action, especially here in Mississippi where timber has been the backbone of local communities for generations. Today, we're taking you inside one of the state's premier wood processing facilities, where century-old traditions meet cutting-edge technology in a symphony of efficiency and precision. And our journey begins deep in Mississippi's dense forests, where skilled operators guide specialized harvesting equipment through stands of southern yellow pine and hardwoods. These aren't your grandfather's loggers with axes and handsaws. Modern harvesters are engineering marvels, each one capable of felling, delimbing, and bucking a tree in less than a minute. The operator sits in a climate-controlled cab, manipulating hydraulic arms with the precision of a surgeon, while computer systems calculate optimal cutting lengths to maximize lumber yield. Here's a fascinating piece of history. Mississippi was once covered by vast longleaf pine forests that stretched across millions of acres. These magnificent trees, some reaching 150 feet tall and living for over 300 years, produced what many considered the finest structural timber in North America. The heartwood was so dense and resinous that buildings constructed from longleaf pine in the 1800s are still standing strong today. Sadly, by the 1930s, less than 3% of the original longleaf forests remained after intensive logging. Today's Mississippi timber industry has learned those hard lessons, practicing sustainable forestry with rotation cycles, replanting programs, and careful management that ensures forests remain productive for future generations. Once felled, these logs are loaded onto specialized timber trucks using hydraulic knuckle boom loaders. It's fascinating how these trucks are designed specifically for the task, with their distinctive stanchion pulls and chains keeping the precious cargo secure during the journey to the mill. It was dangerous, grueling work that required intimate knowledge of river currents and weather patterns. When those trucks roll through the mill gates, they're entering a facility that represents the culmination of over 2 centuries of American sawmill innovation. This particular Mississippi operation processes approximately 180 million board feet of lumber annually, supplying everything from construction framing to fine furniture manufacturers across the country. NTHE first stop is the log yard, and this is where modern technology really starts to show its worth. Logs are offloaded and sorted using a sophisticated system that would have amazed the sawyers of yesteryear. Back in the 1800s, log sorting was done entirely by eye and experience. Today, optical scanners measure each log's diameter, length, and even detect internal defects using advanced imaging technology. Computer algorithms then determine the optimal processing path for each individual log, maximizing the recovery of high-grade lumber while minimizing waste. NTHE sorting system uses hydraulic log decks that can handle logs ranging from small pulpwood to massive old-growth specimens over 3 feet in diameter. It's a carefully choreographed dance of conveyors, chains, and sorting arms, all working in perfect harmony to ensure each log reaches the right processing line. Now here's where things get really interesting. Before any log can be sawn into lumber, it needs to be debarked, and this Mississippi facility uses the ZE 1105 rotor debarker with the innovative VarioPress system. Let me tell you about this remarkable piece of German engineering, because it represents a quantum leap in debarking technology. And traditional ring debarkers, which have been around since the 1960s, work by pressing the log against stationary tools in a circular configuration. They're effective, but they're also inflexible. The ZE 1105 rotor debarker takes a completely different approach. Instead of a static ring, it uses a rotating drum equipped with specialized debarking tools that actively engage the log surface. The VarioPress system is the real innovation here. It automatically adjusts the pressure and position of the debarking tools based on real-time feedback from sensors monitoring bark thickness, wood hardness, and log diameter variations. And this adaptive pressure control is crucial because not all logs are created equal. A pine log harvested in winter will have bark that behaves differently than one cut in summer. Hardwoods like oak require different treatment than softwoods. The VarioPress system handles all these variations seamlessly, removing bark efficiently while minimizing fiber loss. In the timber industry, every fraction of an inch matters. Even saving 1/16 of an inch on the surface of a log translates to significant lumber recovery across millions of board feet annually. Modern facilities like this Mississippi mill routinely achieve recovery rates exceeding 75%, and some highly optimized operations push even higher. That improvement didn't happen overnight. It's the result of decades of engineering refinement. From thinner saw blades with reduced kerf to computerized optimization systems that ensure every cut maximizes value. NTHE debarked logs emerge, clean and ready for the primary breakdown process. They're conveyed to the head rig, which is essentially the heart of any sawmill. This facility uses a modern band mill configuration, where a thin band saw blade running at high speed makes the initial cuts. The advantage of band mills over the old circular saws is reduced kerf. That's the width of wood removed by the sawing action. A thinner kerf means more lumber from each log. NTHE evolution of saw blade technology is a story unto itself. Early sawmills used massive circular saws that could be 6 feet or more in diameter, with teeth the size of your thumb. These brutes were incredibly powerful, but also incredibly wasteful, removing a 1/4 inch or more of wood with every cut. The transition to band saws in the mid-20th century was revolutionary, but those early bands had their own challenges. They'd break, they'd wander off course, and they required constant attention from skilled filers, who would sharpen and tension the blades by hand. Today's carbide-tipped bandsaw blades can run for hours without sharpening, maintain straighter cuts, and remove as little as 1/8 of an inch of material per kerf. That difference might not sound like much, but across millions of cuts, it adds up to thousands of additional board feet of lumber. What's remarkable is the level of automation involved. The sawyer, who once relied purely on experience and intuition, now works in partnership with computer optimization systems. Laser scanners create a 3-dimensional profile of each log as it approaches the head rig, and sophisticated software calculates the optimal cutting pattern in milliseconds. The sawyer can accept the computer's recommendation or override it based on their expertise, a beautiful blend of human judgment and machine precision. After the head rig makes the primary cuts, the resulting cants and slabs move to the gang saws and resaws for further breakdown into dimensional lumber. These secondary saws can process multiple pieces simultaneously, achieving cutting speeds that would have seemed impossible just a generation ago. The whole system is designed to maintain a continuous flow, with lumber moving from one operation to the next without unnecessary handling or delays. NTHE final dimensions are achieved through edging and trimming operations, where computer-controlled saws remove wane, that's the bark edge or irregular surface, and cut boards to precise lengths. Every piece is graded either by trained inspectors or automated grading systems that use cameras and artificial intelligence to evaluate lumber quality according to industry standards. This Mississippi mill represents more than just modern manufacturing efficiency. It's a link to America's timber heritage, continuing traditions that built this nation while embracing innovations that ensure sustainability for future generations. Now we're crossing the Atlantic to visit the Drena sawmill in Ireland, and folks, if you think the Mississippi operation was impressive, wait until you see what our Irish friends have accomplished with their timber processing facility. There's a rich history of forestry in Ireland that goes back thousands of years, and modern mills like Drena are writing the latest chapter in that long story. And Ireland's relationship with its forests is complex and fascinating. By the early 1900s, less than 1% of Ireland remained forested after centuries of clearing for agriculture and shipbuilding. But through dedicated reforestation efforts, particularly in the latter half of the 20th century, Ireland's forest cover has been steadily increasing. Today, mills like Drenagh process a mix of both native species and introduce conifers like Sitka spruce, which has thrived in Ireland's mild, moist climate. Here's something most people don't know. Ireland was once called the land of saints and scholars, but it could just as easily have been called the land of oak forests. Ancient Ireland was heavily forested, with vast oak woods that the Celts considered sacred. These forests supplied timber for everything from the round towers and monasteries of early Christian Ireland to the longships of Viking raiders. When the English Navy needed timber for their warships in the 1600s and 1700s, Irish oak was prized above almost all others for its strength and durability. The HMS Victory, Admiral Nelson's flagship at Trafalgar, contained Irish oak in her construction. But this demand came at a terrible price. By 1800, Ireland's native forests had been decimated, and the ecological and economic consequences lasted for generations. And our journey begins, as always, in the forest itself. Irish forestry operations have their own distinctive character, shaped by the landscape and climate. The forests here tend to be managed plantations, carefully cultivated rotations of spruce, pine, and larch that reach harvestable maturity after several decades of growth. The timber harvesting equipment you'll see operating in these forests represents the same evolution in technology we discussed earlier, but adapted for Ireland's often challenging terrain, steep hillsides, boggy ground, and narrow forest roads that require skill and patience to navigate. Modern Irish harvesters are typically tracked machines, giving them stability on slopes that would be treacherous for wheeled equipment. The operators are highly trained professionals who understand not just how to cut trees, but how to work in harmony with Ireland's environmental regulations, which are among the strictest in Europe. Every harvest is planned to minimize ecological impact, with buffer zones along streams and careful attention to regeneration. Once harvested, the logs are loaded onto articulated timber trucks. You'll notice these European haulers look a bit different from their American counterparts, typically featuring a different stanchion configuration and often incorporating trailers that can navigate the winding roads of the Irish countryside. These trucks make their way to Drenagh's mill yard, where the real transformation begins. The Drenagh sawmill represents a significant investment in Ireland's timber processing infrastructure. Facilities like this are relatively rare in Ireland compared to the massive timber-producing regions of Scandinavia or North America, making operations like Drenagh particularly important to the local and regional economy. They're processing timber that might otherwise be exported as raw logs, adding value and creating skilled jobs in rural communities. NTHE Log Reception Area at Drena is a study in organized efficiency. As trucks arrive, their loads are systematically offloaded, and the logs are sorted into categories based on species, diameter, length, and intended end use. This sorting process is critical because different products require different processing approaches. Logs destined for construction lumber follow one path, while those selected for pallet manufacturing or other industrial uses take different routes through the facility. NTHE sorting system employs a combination of manual grading by experienced timber scalers and automated measurement systems. There's an art to log grading that you can't entirely replace with technology. Experienced graders can spot defects, assess quality, and make decisions that optimize the mill's production in ways that pure data analysis sometimes misses. It's that human element, that accumulated wisdom of decades in the timber business, that makes the difference between a good sawmill and a great one. Irish sawmills have traditionally processed a high proportion of softwood species, particularly Sitka spruce, which accounts for more than half of Ireland's forest cover. This species was introduced from North America in the late 1800s and has proven remarkably well suited to Irish growing conditions. Sitka spruce grows relatively quickly, produces straight-grained timber, and has excellent strength-to-weight ratios, making it ideal for construction and structural applications. NTHE introduction of Sitka spruce to Ireland is itself an interesting tale of botanical adaptation. Native to the Pacific coast of North America from California to Alaska, Sitka spruce was first planted experimentally in Ireland in the 1830s. Foresters discovered that Ireland's cool, moist climate, particularly in the western counties, mimicked the tree's native habitat almost perfectly. By the 1950s, when Ireland launched ambitious afforestation programs to rebuild forest cover, Sitka spruce became the species of choice. Today, a tree that once grew in the temperate rainforests of the Pacific Northwest has become synonymous with Irish forestry, thriving in places like County Wicklow and County Galway. At Drenagh, the logs undergo preliminary processing that prepares them for the main sawing operations. Like any professional sawmill, debarking is an essential first step. Bark contains dirt, stones, and other contaminants that would quickly dull or damage expensive saw blades. It also harbors insects and fungi that could compromise lumber quality, if not removed. The debarking process at Drena strips away this outer layer, revealing the clean wood beneath and preparing each log for optimal sawing. After debarking, we come to one of the most interesting aspects of Drenagh's operation, their use of a four-sided chipper canter saw. Now, if you're not familiar with sawmill terminology, let me break this down, because this is where things get technically fascinating and where you really see the evolution of sawmill technology. And traditional sawmills, like the one we just visited in Mississippi, typically use a head rig that makes one or two cuts at a time, gradually breaking down a log through multiple passes. A chipper canter takes a fundamentally different approach. It processes all four sides of a log simultaneously in a single pass. Imagine a log entering a machine and emerging seconds later as a perfectly square timber, with all the rounded edges removed. That's the magic of a chipper canter. The term chipper refers to how these machines remove wood from the log. Instead of using traditional saw blades for the rough cutting of the outer portions, chipper canters employ heavy-duty chipping heads equipped with large cutting knives. These knives rotate at high speed, literally chipping away the outer wood to create flat surfaces. The chips produced in this process aren't waste. They're valuable byproducts sold to paper mills, particle board manufacturers, and biomass energy facilities. The four-sided configuration means the log is simultaneously engaged by chipping heads on the top, bottom, and both sides. In the center of this aggressive cutting action, precision circular saws or band saws make additional cuts to create dimensional lumber from the now squared timber. The coordination required is remarkable. We're talking about multiple cutting systems operating in perfect synchronization at production speeds that can process a log in mere seconds. This technology has its roots in Scandinavian sawmill innovation from the 1960s and 1970s. Engineers in Sweden and Finland, dealing with large volumes of relatively uniform plantation-grown conifers, developed these high-speed processing systems to maximize efficiency. The chipper canter concept revolutionized sawmilling in regions with similar timber resources, and its adoption spread worldwide. The Scandinavian influence on modern sawmilling cannot be overstated. Countries like Sweden and Finland, with their vast forests and relatively small populations, had to innovate to remain competitive in global timber markets. They pioneered not just chipper canters, but also automated sorting systems, computer optimization, and integrated production concepts that linked harvesting operations directly to mill production planning. Swedish companies like Söderholm and Kara, and Finnish firms like Viisto and Finnos, became world leaders in sawmill equipment manufacturing. Their machines are found in operations from Russia to South America, from New Zealand to Ireland, each one representing decades of accumulated engineering knowledge and continuous refinement. At Drena, the four-sided chipper canter is optimized for the types of logs they process most frequently, medium-diameter softwood logs that benefit from this aggressive, high-speed approach. The machine is a marvel of engineering, with each chipping head powered by substantial electric motors, the cutting knives precisely ground to maintain optimal geometry, and sophisticated controls that adjust cutting parameters on the fly. Here's something that really showcases the sophistication of modern milling. Before each log enters the chipper canter, it passes through a scanning station. Laser scanners and cameras map the log's geometry in 3 dimensions, identifying its diameter at multiple points, detecting any crook or sweep in the trunk, and even spotting knots or other internal features. This data feeds into the mill's optimization software, which calculates in real time how to position and orient the log for maximum lumber recovery. The optimization system considers dozens of variables: current lumber prices for different grades and dimensions, the specific characteristics of this particular log, the capabilities and current setup of the chipper canter, and even the downstream capacity of the facility. In milliseconds, it determines the optimal cutting solution and automatically adjusts the chipper heads and saws to execute that solution. It's artificial intelligence and machine learning applied to an industry that many people still think of as old-fashioned and low-tech. There's an interesting parallel here to the craftsmanship of the past. Old-time sawyers developed an almost supernatural ability to read logs. They could glance at a log and know instinctively how to saw it for best results, sensing where knots would be, predicting how the wood would behave, anticipating problems before they occurred. That knowledge took decades to develop, and was passed down through apprenticeships and mentorship. Today's optimization systems are, in a sense, an attempt to capture and codify that accumulated wisdom, combining it with computational power and precision measurement that no human could match. The best mills understand that you need both: the technology to process data and execute cuts with perfect precision, and the experienced human operators who can interpret what the machines are telling them and make judgment calls when necessary. And as the squared timber exits the chipper canter, it moves to secondary processing equipment. Gang saws, resaws, and edgers further break down the timber into precise dimensions. These downstream saws are typically thinner kerf machines, taking much finer cuts now that the heavy work of primary breakdown is complete. Each piece of lumber is tracked through the system, with the mill's computer knowing exactly where every board came from and where it's going. The edging process deserves special mention because this is where much of the final value is determined. Edgers remove the irregular edges from boards, creating straight, parallel sides that meet grading standards. But here's the clever part. Modern edgers don't just make straight cuts. They make optimal cuts. Computer vision systems scan each board, identifying defects like knots, splits, or staining. The edger then makes strategic cuts that maximize the recovery of high-grade, clear lumber, while segregating lower-grade material. A single board might be ripped into multiple pieces of different widths, each one optimized for its best and highest use. End trimming to final length happens downstream, where precision saws cut boards to standard lengths demanded by the market. In Ireland and throughout Europe, metric dimensions predominate. You'll see lumber cut to lengths like 3.0, 3.6, or 4.8 meters, rather than the even-foot lengths common in North America. This final trim operation also removes end defects and ensures each piece meets quality standards. NTHE Drena operation incorporates extensive material handling systems that might not be glamorous, but are absolutely essential to efficient production. Conveyors, transfers, sorting systems, and stacking equipment keep lumber moving through the facility at a steady pace. In a modern sawmill, minimizing handling time and maintaining continuous flow are critical to productivity. Every moment a piece of lumber sits idle is lost opportunity. One aspect of European sawmills that's particularly noteworthy is their attention to resource efficiency and environmental performance. EU regulations regarding emissions, waste management, and energy consumption are stringent, and facilities like Drena have responded by implementing sophisticated systems to capture and utilize every possible byproduct. The bark removed during debarking becomes fuel for biomass boilers that generate heat and power for the facility. The chips from the chipper canter are sold as raw material for other industries. Even the finest sawdust is collected and pressed into pellets for heating fuel or animal bedding. This comprehensive approach to resource utilization reflects both environmental responsibility and economic savvy. In the European timber industry, the concept of the cascade use of wood has become fundamental, using wood materials in the highest value application possible, then successively using byproducts in lower value but still useful applications, finally ending with energy recovery from material that has no other practical use. It's an elegant system that maximizes the value derived from every tree harvested. NTHE historical context makes these modern operations even more interesting. Ireland's sawmill tradition goes back centuries, with water-powered mills operating along rivers throughout the island. The Great Famine of the 1840s devastated Ireland's population and economy, and the timber industry suffered along with everything else. The 20th century saw periods of both growth and decline, with Ireland's entry into the European Union in 1973 bringing new opportunities and eventually significant investment in forestry and processing. Today's Irish sawmills like Drena operate in a global marketplace, competing with large-scale operations in Scandinavia, the Baltic states, and Eastern Europe. Success requires not just efficient production but also strategic positioning in markets, quality control that meets exacting standards, and continuous investment in technology and training. The four-sided chipper canter represents exactly this kind of strategic investment, a substantial capital expenditure that pays dividends through increased productivity, improved lumber recovery, and reduced operating costs. And watching Drenah's operation, you're seeing the convergence of multiple streams of innovation. Scandinavian sawmill engineering, computer optimization algorithms developed by specialized software companies, sensor technology from industrial automation suppliers, and the accumulated practical knowledge of generations of sawyers and millwrights. It's a powerful reminder that even in traditional industries like timber processing, innovation never stops. NTHE lumber, emerging from Drenah's production lines, finds its way into construction projects throughout Ireland and beyond, into manufacturing facilities producing everything from furniture to wooden pallets, into merchants, yards supplying builders and contractors. Each board carries with it the story of its origin in Irish forests and its transformation in this sophisticated facility where tradition and technology work hand in hand.